Hi there, this is Professor Shannon Gracie, and today we'll be starting off with some college algebra material. So this is Precalculus 1. The first section covers the distance and midpoint formulas, graphing utilities, and introduction to graphing equations. So just a word of warning, it's going to be a kind of a long section because it is, they basically, in the first few sections of this textbook, which is, by the way, Precalculus with Sullivan and Sullivan, and what they do is they jam a bunch of intermediate algebra topics into chapter 1 and in chapter 2 as well. So just be patient and make sure you leave enough time for your work and you should be fine. So here we go. If you want to read over our goals for the class today, I've got them bulleted there. I figure you can read them on your own, so we will go straight to our warm-up. So since this is the first section of our class, let's think about these kinds of things for our warm-up. What grade do you want to earn in this class? Well, okay, most of you guys probably were thinking, A, I want to earn an A, or at least a B, because most people taking this class, many people taking this class are going on to Precalculus. So let's just think positively and say, hey, I want to earn an A or a B. Okay? So for each unit of the class, so how many units is this class? This is a 4-unit class. So how many hours should you spend on the class per week? Well, you may have heard this before. It's 2 hours per unit at least, and this is outside of class, which in our case would equal to, good, 8 hours per week. How many hours of class time? If you were coming on campus to take this class, how many hours would you be spending? That is right. You'd be spending 4 hours per week. So, how many hours for homework, test prep, etc.? Above and beyond the 4 hours per week, you should be doing at least this 8 hours a week that we talked about. So at least 8 additional hours. And that's additional from this. And when should you work on math? When you get home after like going to school and working for 12 hours, is that a good time? Probably not. You're going to be exhausted. So it's best to work on math when you're, rested. You should be rested and alert. Much as I, would love to, math and beer or math and wine don't usually mix very well. You make up a lot of your own math that way. And I speak from experience. So here we go. Let's go ahead, now that you have an expectation that, hey, you're going to probably be working at least 12 hours a week on this class, let's get going. So I'm going to go kind of quickly through this part. As I said, it's all review. And if you're having any trouble, I have videos for both beginning and intermediate algebra classes, and those can be found on YouTube. They can be found on www.mathchick.net. So www.mathchick.net. And they also can be found, I'll probably put some pertinent videos in the course management system on the Pearson My Lab. Okay? So I'll just say this has introductory and intermediate algebra. Videos. Okay, so here we go. Rectangular coordinates. We locate a point on the real number line, so just a single real number line, by assigning it a single real number called the coordinate of the point. We'll be doing a lot of work in a two-dimensional plane. So in this situation, points are located by using two numbers. The rectangular or Cartesian coordinate system consists of two real number lines. One of them is horizontal, and one is vertical. The horizontal line is called the x-axis, and the vertical line is called the y-axis. So when we get into functions, we often name them different things, but this will suit for the review. The point of intersection is located at the ordered pair, you remember? Good, 0, 0. And it is called the origin. Assign coordinates to every point on these number lines using a convenient scale. The scale of a number line is the distance between 0 and 1. It's a 0. Once you set the scale, this is important, it stays the same on that particular axis. So you could have different scales on the x and the y-axis, but within the x-axis and within the y-axis you want to be the same. So if you're sketching a line, say, that has x-coordinates that can be easily viewed using a scale between -6 and 6, and y-coordinates that are better viewed between -1 and 1, you could set the scale for the x-axis as 1, but the y-axis you might want to kind of zoom in on a little. So you might want to have that one be, 0.5. You might want it to be 0.1, right? Something like that. Why don't we call this 0.1, a tenth? So points on the x-axis to the right of that O means origin are associated with positive real numbers, and those to the left of the origin are associated with, good, negative real numbers. Points on the y-axis above the origin are associated with positive real numbers, and those below the origin are associated with negative real numbers. The axes divide the plane into 4 regions called quadrants. The points located on the coordinate axes are not in any quadrant because they're not inside the quadrant, they're on the edges. So each point in the rectangular coordinate system corresponds to an ordered pair of real numbers in the form x comma y. Okay, so let's take just kind of a picture of what we saw going on. So this is a coordinate plane, and you can label the axes, X and Y. Now, this ordered pair right here is called the origin. So this ordered pair is the ordered pair 0, 0, called the origin. I'll do this in green. So here we go. Okay, so far? All right. Now, you decide on the scale. So if we use the scale that we decided on above, I think we had said that the scale of X was 1. Basically, each of these little tick marks would represent 1 unit. So it turns out that I used this plane all through our guided notebook. So basically, if you see this coordinate plane and you do a scale of 1, basically it'll be plus or minus 10. So just to kind of make sure you're on the right track, 1, 2, 3, 4, 5 would be in the middle. 1, 2, 3, 4, negative 5 would be in the middle over here. Okay, so far? Good. So we had said the y-axis, we would do 0.1 for our scale. So what that means is that each one of these little boxes here is going to be 0.1. So up here, we would be at 1.0. Midway through, we'd be at 0.1, 0.2, 0.3, 0.4, 0.5, or a half. And down here, we'd be at, we want to stick to the same, so negative 1.0, and then 1, 2, 3, 4. Halfway through would be at negative 0.5. And you don't have to put that, that's just using the example we were using above. Right? Now, if we think about the quadrants, this is how the quadrants are labeled. This first quadrant, where the X and the Y value are both going to be what? You'd be moving to the right of 0 and up, so they would both be good, positive. So you'll have positive numbers, a positive X value and a positive Y value as coordinates in the ordered pair for all the infinitely many points in that quadrant. Now over here in quadrant 2, so we go counterclockwise, the X is moving to the left of 0, so it's going to be a negative, and the Y is still above, so it would be a positive. And then down here in quadrant 3, what do you see? Very good. Negative, negative. And then in quadrant 4, you would have, good, the X would be positive, the Y would be negative. Now this is really important to understand this concept when you get to trigonometry, because in the second part of our pre-calculus course, we learn about the trigonometric functions, and they all sort of repeat within each quadrant, and they only really differ by a sign. So if you know the signs of a given ordered pair in a quadrant, that's going to help. That's going to help you. Okay, so let's see how much you remember about plotting ordered pairs. So take a look at these 3 ordered pairs. So I'm looking at these guys, and you know what? I think just doing the standard scale, which is plus or minus 10 on each quadrant, or on each axis rather, is going to be just fine. So that's how I'm going to label it. And you go ahead and, if you want to, you can pause the movie and you can plot those 3 points and label them with the corresponding letters. Okay, let's see how you did. So point A is 2, 5. They're both positive. So we move 2 to the right, and then 1, 2, 3, 4, 5 up. So that's point A. And then point B is negative 3, 7. So 3 to the, good, left. 1, 2, 3. And then 1, 2, 3, 4, 5, 6, 7, up. And that is point B. And point C, we are going 2 to the left and 0 up. So this is point C. So let's talk about where these guys are located. Point A is located where? Good. Quadrant 1. How about point B? Quadrant 2. Very good. How about C? That's kind of tricky, right? This is located on the x-axis. Awesome. Doing okay so far? Woohoo! All right, let's keep going. Now I want you guys to try this. This is one of those thinker problems. So if you're feeling pretty good about it, pause the movie, try the whole problem. Otherwise, I'll go ahead and work it, and you can work it along with me. So again, I think that the scale on this can be plus or minus 10 for each of the axes. All right, so we're going to go, if you plot these points, this is going to be 0, 3, and then 1, 3, 5, 3, so 1, 2, 3, 4, 5, 1, 2, 3. And then what do we have? Negative 4, 3. So 1, 2, 3, 4, and then up 1, 2, 3. So what do you notice about these these points? They all seem to be falling on which line? Good, a horizontal line that's 3 above the x-axis. So let's just write that in words. The points will all lie on the horizontal line which is in the form, by the way, y equals 3. When you're talking about lines and you say y equals 3, that's the horizontal line with the y-intercept 0, 3. But we'll put in parentheses to describe this. This would be the horizontal line three units above which axis? Good, the x-axis. Okay? All right, moving right along. Next up, we start talking about graphing utilities. So we're going to be, using our graphing calculator throughout the course. So all graphing utilities graph equations by plotting like infinitely many points. It's like amazing. So the screen itself consists of small rectangles which are called pixels. The more pixels the screen has, the better the resolution. So when a point to be plotted lies inside a pixel, the pixel is turned on, it lights up. So our graphing calculator is kind of weird. When it lights up, it's actually black. So it blacks up. I always had a little bit of trouble when I was first learning how to use the graphing calculator. So you'll see a black square if you plot a single ordered pair. So the graph of an equation is a collection of lighted pixels. Okay, so the screen of a graphing calculator will display the coordinate axes of a rectangular coordinate system, but you need to set the scale on each axis. You must also include the smallest and largest values of x and y that you want included in the graph. This is called setting the viewing rectangle or setting the viewing window. So x-min is the smallest value of x shown on the viewing window. X-max, largest value of x shown on the viewing window. This next one is the scale of x, so the number of units per tick mark. On the x-axis. So going back, real similar, y-min is going to be the smallest value of y shown on the viewing window. Y-max, the largest value of y shown on the viewing window. And y-scale is the number of units per tick mark. On the y-axis. Okay, so let's just take a look. I've made some viewing windows for you. I'll be teaching you how to do all this soon, but it's important for you to be able to see these things and recognize what's going on. So I've copied and pasted a point that's been plotted on this graph. So let's fill in the information, because without understanding the scale and naming the axes, it's not very informative. So if we name it the axes x and y, the x-min is -5. So -5 is over here and +5 is over there from x-min and max, respectively. The x-scale is 1, so each of these is 1 unit. So if we wrote the whole thing, this is what the x-axis would look like. Good so far? All right. Y minimum is also -5 and the maximum 5. But look, there's not as many tick marks, are there? So they're trying to be tricky here. So let's take a look at the scale. Do you see how the y scale is 2? So here, this one here is 2. This is 4. So 3 is going to be in between 4 and 2, and 1's going to be in between the origin and 2. So similarly, that's -2 and -4. So assuming that this isn't, that the coordinates of this ordered pair shown are integers, what would this ordered pair be? Good, we went 1, 2 to the right, and it looks like we went 1 up. So 2, 1. You doing okay? Awesome. All right, so here we go. Part B, the viewing window. What do you think? Well, let's start with the min and max for x. Minimum x value, good, 0. Max was 15. I'm looking left to right here. And the scale, okay? Well, it's not by ones, because look, 1, 2, 3, 4, 5, that doesn't get us to 15. So let's try by 3. I think if I went 3, 6, 9, 12, 15, do you see how that works? Good. So our scale is 3. How about our y min? Nice, -50. Y max, 20. And the y scale, let's do the one with 20 because it'll be the same down here. So there's 1, 2, 3, 4 tick marks. So if we went 5, 10, 15, 20, that works. So the y would be 5, 10, 15, and then 20. So the y scale is 5. And then down here it'd be like -5, -10, etc. All right. Good. Moving right along. So, next up, let's just talk about the distance formula. I always had the worst time remembering this formula. So let's just sort of, draw a picture and see what we have going on. So let's say we've got 2 points. Let's say this is our first point. Actually, we'll just do this in blue. I love blue. And so let's call this point 1, which equals x1, y1. And then somewhere up here, point 2 will be x2, comma, y2. So we'll put this point, I don't know, how about right here? So, if we want to find the distance, we're considering, the shortest distance is going to be a straight line. So if we want to find the distance between these 2 points, if you just kind of draw this line here, then what's going to happen is, do you guys remember the Pythagorean theorem? It was something like, good, a squared plus b squared was equal to, nice, c squared. So you had like a triangle going on, and it had to be a right triangle. C was the hypotenuse, and then A and B were the sides. And so, do you see that we could do this? We could draw in a right triangle right here, and we could use the Pythagorean theorem to figure out the distance. So what we have to do is we have to figure out what this length is, and we have to also figure out what this length is. Okay? So the yellow length is going to be a change in x or y values. It's a vertical line, so it's a change in, good, y values. So basically, this distance would be y2 minus y1. And if you want to be specific, because these could be drawn in any format, so you could say the absolute value if you wanted to. That's just going to ensure that it's positive. So that is the measure for the yellow length. Now, similarly, this blue length could be written as the absolute value of x2 minus x1. So if you come over here and think about that, let's see what we have going on. So if we call this the distance and designate it between P1 and P2. So the distance between P1 and P2 and if we consider that to be squared, because if we square an absolute value, what's going to happen? Good. That you don't need the absolute value because you've ensured positiveness, right? So let's see what we have going on. We would have one leg of the triangle, the blue leg, is, let's write it like this, absolute x2 minus x1 squared. And then we'd be adding to that, good, absolute y2 minus y1 squared. So this distance between P1 and P2 squared is just x2 minus x1, the quantity squared, plus y2 minus y1, the quantity squared. Now, if we square root both sides and we only consider the positive root because length is positive, then we'll get the distance between P1 and P2 will be equal to the square root of x2 minus x1 quantity squared plus y2 minus y1 the quantity squared, and you're done. That's it. This is weird right here, sorry. All right, so let's write it down officially. The distance formula, the distance between 2 points, P1 equal to x1, y1, and P2 equal to x2, y2, denoted by the distance between P1 and P2 is what we wrote up here. Okay? Good. All right, moving right along. Find the distance between each pair of points. So I'll leave that formula up here so we can see it. So the distance between P1 and P2 is the square root of. So what's my x2? Good. 6, and then minus, be careful with the signs, the minus is in that formula, and that quantity is going to be squared, and we'll add to that 2 minus negative 3 the quantity squared. So this distance will be equal to, good. We'll have, do you see 6 minus negative 4 is 10, and 10 squared is 100? And then 2 minus negative 3 is 6, and 6 squared is 36. Oh, I was making up my own math. See, I do it too. It's 2 minus a negative 3 is 5, and 5 squared is 25. It's been a long day. All right, so continuing, you're going to want to write this as a simplified radical, and then you can approximate it using your graphing calculator. So this will be equal to root 125. So remember, when you're doing problems like this, you're looking for perfect squares. So here, perfect squares that are, everything's going to be multiplied. So do you see that this is equivalent to 25 times 5 under the radical? So the exact result will be the square root of 25 is 5, and then you have root 5 remaining, and that's in linear units. Now, the approximate result, I'll put a wavy equals. You could also do an equals with a dot. This is going to be, let me get the calculator up. So the approximate result, by the way, I use a TI-83 to show things, so they might look a little different than the newer calculators. But if you're using a TI-84, that you'll have the same keystrokes, I believe. So here we go. We want to do 5 times the square root of 5. So those are the keystrokes to enter. And then we'll get a result of approximately, we'll go to the nearest 100, and I believe we got 11.18 units. All right. So the next one, believe it or not, it's actually easier, even though it might look a little scary. But again, if you feel confident and you want to pause the movie, that's great. You can work it through and then check to see how you did. So the distance between these guys will be, so x2 is 0, x1 is a, and then y2 is 0, and y1 is a, and those will be squared. So this will be the square root of a squared plus a squared. And we'll have two of those. Those are like terms. Now, we want to make sure that we have a positive distance. So the a is being squared. So we can pull out an a, but be careful, you have to write that as absolute a to ensure that it's positive. And then we have times root 2. Or you could write it as root 2 times the absolute value of a. And we're done. This is also in linear units. All right. Moving right along. An application of this thinking is figuring out if, the ordered pairs that you've been given form a right triangle, right? So beware, I have a typo here. We need to change this guy to negative 11. Okay, so it's 10 comma negative 11 is point C. So here we go. The first step, plot each of the ordered pairs. So go ahead, pause the movie, and why don't you guys plot those ordered pairs. Gonna have a sip of wine. It is way after 5 o'clock. Cheers. So be careful of your scale, right? We've got things that go above and below 10. So I'm going to just go ahead and have each tick mark be 2 units for both scales. So halfway through will be where the 10s are. Okay, so far? All right. So here we go. Point A, negative 2, and then up 5. So 2, 4, 5. So this is point A. Point B is at 12, 3. So 10, 12, 2, 3. So that's point B. And point C is at 10, negative 11. So 10 and then 2, 4, 6, 8, 10, negative 11. That's point C. So drawing this triangle that connects these points. I don't like that one. Let's see what we have going on. All right, so we've got this triangle, and we want to figure out if it forms a right triangle, right? So to verify that the triangle is a right triangle, we need to find, one of the ways you can do this problem is you can find each of the distances between the different lengths. So you'd be doing AB, AC, and BC, finding those distances, and then adding the squares of the sides and see if it equals the square of the hypotenuse, right? So let's check it out. We'll do the sides of the triangle first, the distances for the sides. So that'd be AB and BC. So the distance between A and B, points A and B, are, so you can refer back to what the ordered pairs were. I'll write them again. The ordered pairs for this guy, A was -2, 5. B was 12, 3. And C was the one that we had changed, 10, -11. So the distance between A and B will be 12 minus -2 squared plus 3 minus 5 squared. So the distance between A and B is 12 plus 2 is 14. 14 squared is 196. And then 3 minus 2 is -2. And -2 squared is 4. So the distance between A and B will be √200. So simplifying, we're not doing decimals on this guy until we get to the area. 200 is 100 times 2. So the distance, the exact distance, will be 10 √2, because 10 squared is 100. All right, so the distance between, we said next we were going to do B and C. Those are the two sides of the triangle. So this will be the square root of 10 minus 12, the quantity squared, plus -11 minus 3, the quantity squared. So the distance between points B and C is we'll get -2, and then -2 squared is 4, and over here we'll get -14, and -14 squared is 196. So do you see we're going to get the same result? This is √200, which we showed before is equal to 10 √2. And these are in units, linear units. All right? So let's take a look at the distance of AC. So the distance of A between points A and C will be the square root of 10 minus -2 squared plus -11 minus 5, the quantity squared. So this will be root 10 plus 2 is 12, and 12 squared is 144. And then -11 minus 5 is -16, and -16 squared is 256. So the distance between A and C is the square root of 400, and the distance of A and C is, distance between A and C is 20 units. Good so far? So now we have, the calculations that we needed. So now comes the verification, right? All right. So the verification, the sum of the squares of the sides has to equal the square of the hypotenuse. So the distance between A and B, the quantity squared, plus the distance between B and C, the quantity squared, is that equal to the distance between A and C squared. So let's check it out. We got this distance was 10 root 2, as was this distance. And we want to know, is that equal to, we got 20 units for this guy. So 10 root 2 squared is going to be 200. Is that equal to 400? And yes, 400 equals 400. Check. That is true. So we have verified that triangle ABC is a right triangle. All right, so now they want us to find the area. So remember that the area is the base times the height. So let's look at our picture. AC was the hypotenuse. So do you guys see that this here is the right angle? So the base, you could either call the base AB or BC, and then the height will be the other leg of the triangle. So in general, area of a triangle is half times base times height. So the area is equal to half, and the base is equal to the height in this case. So we will get half times 100 times 2, because root 2 times root 2 is 2. The 2's divide out to be 1. So at the end of the day, we get an area of 100 square units. And there we go. So that's one of the applications of distance. All right, so now the midpoint formula, a little easier to work with, all right? So a line segment who has endpoints P1 equals to x1, y1, and point 2 is x2, y2. The midpoint, denoted by capital M, will be M equals, it's going to end up being some ordered pair, and in particular the ordered pair, it's the average of the x values as the x coordinate, and the average of the y values is the y coordinate. That's how I remember this one. All right, so let's do a couple to get it on your brain. So the first guy, the midpoint will be summing the x values and dividing by 2, and then summing the y values and dividing by 2. So the end result will be, looks like negative 1/2 and then positive 11 halves. Good so far? All right. So this one, again, more of a thinker problem that actually turns out to be pretty easy. It'll be a plus 0 over 2, comma, a plus 0 over 2. So the midpoint will be a over 2, comma, a over 2, whatever a is. All right. Okay, so in calculus, you are going to be curve sketching. And you're going to have a lot more tools than you learn here in pre-calculus, but we can still learn a lot of stuff. So you need to have your basic, skills for plotting points in your, well honed before you get into the harder graphs. So let's check it out. Graph equations by hand, plotting points. So an equation in 2 variables call them, I don't know, x and y is fine, is a statement in which two expressions involving x and y are equal. The expressions are called the sides of the equation. Since an equation is a statement, it can be true or false, depending on the value of the variables. Any values of x and y that result in a true statement are said to satisfy the equation. The graph of an equation in two variables, x and y, consists of the set of points in the xy plane whose coordinates x comma y both satisfy the equation. So let's figure out if the given points are points that are on the graph of the equation. So you just check it out. 0, 0. So I'll be plugging in a 0 for x and a 0 for y in this case. So I'll have 0 equals 0 cubed minus 2 times the square root of 0. So just to make sure you're on board with everything, that's the x coordinate. These are the x's in the equation. So these zeros are what I plugged in for x. The y coordinate is also 0, so I plug this 0 in for y. And what we want to see is if we get the same on the left as we do on the right. So do you see we'll get 0 minus 0. So 0 does indeed, we're checking out if this is true. So 0 does indeed equal 0. That's true, so our answer is yes. Alrighty, let's try 1, 1. So again, plugging in the same value for y as we do for x, and we're going to see if we get a true statement. Alrighty. So 1, is that equal to 1 minus 2? 1 is not equal to -1, right? Is not equal to -1, so we would say no. So on this one, actually, let's take the question mark off that last statement because we found that it was true. So this ordered pair, it's a great ordered pair. It just doesn't happen to be on the graph of this equation. What about 1, -1? So plugging in -1 for y. And again, we're plugging in 1 for x. Oops. And see what we got. -1, is that equal to 1 minus 2 times 1? -1 equals -1. Check. So we would say yes. Good so far? Awesome. All right, so here we go. Graphing equations using a graphing utility. So this is something you want to learn how to do. It's helpful in calculus. We don't always use a graphing calculator, but it can be a very, very useful tool. So when you're using a graphing utility, you need to isolate y. So here's just some steps to help us with that. So you can interchange the two sides of an equation. So if you had something like, I don't know, 12x minus 3 is y, that's the same as y equals 12x minus 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. we can also simplify the sides of the equation by combining like terms, eliminating parentheses, etc. So you might have to do a little work in order to isolate y. So let's say you had, I don't know, 3 times x minus 2 plus y equals 5. That would be equivalent to 3x minus 6 plus y equals 5. And you would still keep working on that so that you would isolate y. You would get y alone. Okay. Add or subtract the same expression on both sides of the equation. So if you had something like y minus 5 equals x plus 2, we would want to do what to both sides to isolate y? Good. We would want to add 5. So basically we could say y minus 5 plus 5 is equal to x plus 2 plus 5. So we balanced out the equation by adding the same number to both sides. And then you can multiply or divide both sides of the equation by the same non-zero expression. So let's say that we had 2y equals x minus 4. Right? This would be equivalent to 2y divided by 2 equals x minus 4 divided by 2. Now, I did this on purpose because this is your 2y divided by 2. Actually, let me do those in red. Basically, this is what I'm changing. I'm dividing by 2. So basically, this is equivalent to 2y divided by 2 is equal to, you have to divide each term by 2. So this would be x over 2 minus 4 over 2. A lot of people like to divide both sides. So you have to remember that if you have more than one term, you're dividing each term by that non-zero constant. All right, so here we go. Example 7. Here's just some things so that we can practice isolating y. So here, first of all, we want to get rid of the parentheses. So the negative will distribute through, so we'll have 5 minus x plus 3 on the left side equals 2y. 6 times 1/2 y is 3y, and 6 times 1 we'll have minus 6. So combining the 5 and the 3, I have 8 minus x. 2y and 3y are like terms, so we'll get 5y minus 6. Now, if I want to isolate y, do you see I would need to add 6 to both sides. Now it's up to you. You can add vertically or you can add horizontally. The point is you need to be able to, you need to add the same number to both sides of the equation. So now, where are we at? We want to isolate y, so we divide by 5, or you could multiply by 1/5. So this would be 14/5 minus x over 5 equals y. Whoops, there shouldn't be an equals there. And then writing it a little prettier, I'm going to write this as negative x over 5 plus 14 over 5. And y is isolated. Okay, so now let's look at part B. Part B, we need to add x squared to both sides. So we would have 4y is equal to, I'm going to write it as x squared plus 3. We usually go in descending powers of the variable. So then what do I need to do next? Good. I need to, you either divide both sides by 4 or multiply both sides by 1/4. So we end up with y is equal to x squared over 4 plus 3/4. And we've isolated y. All right. Moving right along. How are you guys doing? Pause the movie and take a stretch if you need to. Okay, so how to graph an equation using the TI-83, TI-84 graphing calculator. Solve the equation for y in terms of x. Enter the equation to be graphed in your graphing calculator. So you use the y equals key. So I'll go ahead and give you some of this in real time. I press the y equals key. I made a picture of where it is. Let me clear this one out. I graphed the equation x squared plus 3 all divided by 4. It was one of the last one that we isolated. So I actually wrote it a different way when I worked it out here. So I'll put it in the same way I wrote it. So I had written it as x squared, there's a little square key right there, divided by 4. And I believe that was was it a negative? Let's see what we got. Hang on. It was up here, I think. Yes, it was positive. So positive. And then plus 3 divided by 4, and you'll see we'll get the same graph. So that's in the y equal menu. So that's where this is right here. Why isn't it going? Well, it's right here. So where the y equals just under the lower left part of the screen. Okay, so then you just hit graph. Now my window right here is not in the standard view. If you go zoom and you go zoom standard, which is number 6, it gives you plus or minus 10 on each axis. So as you see, this is the same picture. I'll bring it back up again. This is the same picture that's there. Okay, so far? All right. So the window, just to show you, this is the window that comes up with the standard. And I also copied that window here for you. All right? Okay, and then if you need to, you adjust the viewing window, right? You can change the X-min and X-max values, the scale, the Y-min, the Y-max values, and that scale, the resolution, whatever it is you need to do, you do so that you can see the picture of that graph, okay? So this one, it's a pretty good, visual for us, so I'm just going to leave it in that viewing window. And let's go down here and see what we've got. Okay, so, oops, there we go. How to use the calculator to create tables. You do the same thing. You need to get that initial graph in your y1, which is your first equation in y. So you do the same thing. Solve the equation for y in terms of x, enter the equation, and then you set up the table. So you can set it up in different ways. In auto mode, the user determines the starting point for the table and the delta table, which is the incremental change in x. Ask mode would ask you to enter values of x, and it would give you corresponding y values. So we can do it right here, right? So if we go to second table set, this table starts at 0. So I'll just plug in what I had put over here, -3. The change in the table is 1. And so when it's in auto and you go to table, this is what you would get. So table is the second function on graph. And you see you get basically ordered pairs at the integers. Now, if I had wanted to set up the table where I wanted to have, let's say, 0.5 as my change in x, and I went back to my table, notice that I would have ordered pairs that were closer to each other. Now, sometimes it's useful to go to the ask feature, right? So if you go to ask for the independent and you go to table, you would enter in an x value. So let's say I wanted to know what x value corresponded to x equal to 10, right? Then it would give me the y value in decimal form. Pretty cool, huh? So the ordered pair, 10, 25.75 is on the graph. So it just depends on what you want to find out. There's also a command, if you noticed on the table set, where you can go down here and you can have this be auto. So by the way, when it's highlighted, it means that the black is the highlight, so you'll see white letters. So I'll go to the dependent variable ask, and let's look at what that does for our table. So see, the x is automatic. That was kind of funky, huh? Let's go to set them up as both ask and see what happens. So let's go to see what happens here. So we could go to a y value, and let's say we wanted to know the x value. It won't let us. We'll learn how to do stuff like that later. It lets us do, I don't know, this one's kind of strange. When we want to find x values that yield certain y values, we'll have different ways to figure that out. So we'll go ahead and do these on. We'll set it up like it was. I don't think we need it anymore. Put them both to auto, and then quit out of there. Okay, so let's see what we have going on next. That wraps up that page. Okay, so here the graph of an equation is given. List the intercepts of the graph. You probably can't see me anymore. I forgot it's getting dark. You might have been happy about that, but I don't know. So here we go. If you take a look, we've got, do you see for x-intercepts, do you see we cross here, here, and here? And on one of them, the x-intercept will be the same as the y-intercept. So, the x-intercept, I like them as ordered pairs, but the program in my math lab, when it asks for the intercepts, it just wants the coordinates. So, the ordered pairs for the x-intercepts, do you see, are at -3, 0, 0, 0, and 2, 0. So in MML is my math lab. In MML, it's going to ask you to just enter in x is -3, 0, and 2. Okay? And I think in the back of the book, if we do any book assignments, that's what happens. So what about the y-intercept? There's only one of them. So where do we cross the y-axis? Good. We cross it at 0, 0. So in MML, it would be y equals 0. So that implies it's a coordinate because we're talking about intercepts. Okay? Awesome. All right, so here we've got a different one. This is an equation here, and let's see where our intercepts are. So the x-intercept, it looks like we've got one at -1, 0, and right over here. So I don't know what you guys think that is. Maybe 5 1/4. We'll estimate that. So the x-intercept, where we cross the x-axis in ordered pairs, we would be at -1, 0, and it looks like approximately 5 1/4, 0. So again, in MML, it would just be x is -1 and 0. No, my bad, -1 and 5.25. So you just enter the coordinates. And the y-intercepts, there's 2 on this one, do you see that? Are going to be, I'll do them in blue, I guess. So it looks like we've got one here, and we've got one here. Let's see where those look to be. It looks to me like, let's call this like 2.9 and -1.9. Does that look all right? Approximately. So this would be the ordered pair 0, -1.9, and 0, 2.9. And then in MML, you would just do the coordinates. So you would say y is -1.9, 2.9. All right, so here we go. We're going to go ahead and graph these equations by hand by plotting points. So don't worry, we're going to go over linear functions and all that good stuff. You know, if you remember that stuff, that's awesome. But if you don't, you can always get it by point plotting. So for part A, I see that, you know, y is isolated in terms of x. So I'm just going to go ahead and, I don't know, what should we plug in? Maybe -2, 0, and +2, something like that. It can be anything you want. And now we have to solve for y to get the dependent variable. So we'll have 3 times -2 minus 9. So y will be equal to -6 minus 9, which is -15. So our ordered pair is at -2, -15. Okay, so far? Awesome. So when I plug in 0 for x, we have 3 times 0 minus 9. So that's going to give us y is -9. So we have the ordered pair 0, -9. So which intercept is that? Good, it's the y-intercept, because there's no movement on the x. The x is at 0, so we cross the y-intercept, the y-axis at -9. And then if I plug in +2, then I'll get 6 minus 9, which is -3. So we have the ordered pair at 2, -3. So notice we have a pretty high y value there. So let's go ahead and label our axes, right? And then I'm going to do the x-axis just from -10 to 10. So the scale is 1. But let's have this guy be a scale of 2. So our graph will look like -2 and then 2, 4, 6, 8, 10, 12, 14. Oh, my bad, it's negative, so we got to go down. So left and then down, 2, 4, 6, 8, 10, 12, 14, 15 down. So that's my -2, -15. 0, -9, 2, 4, 6, 8, 9. And then 2, -3, 2, 3. So this is 2, -3. This was 0, -9. See how it crosses the y-axis? And this guy was the -2, -15. And then connect the dots. That's not going to be good. So it's good to use kind of a straight edge on these. We're going to put arrows at the end to show that it'll behave this way forever. And now, here's the fun part. We want to verify this using our graphing calculator. So we go to our y equals, we clear this guy out, and do you see we have y equals 3 times x, and then minus 9. So if we graph it, let's see how it looks. Now notice it looks a little bit different. Okay, so I think we should check our window. And do you see our scale on our x-axis is the same? But the scale on the y-axis is different. So let's do the scale the same so we can kind of match the graphs. And then the scale we said was 2. So let's graph this and see what it looks like. Okay. We'll take a screenshot. Paste our results. Now another thing to consider, I've got a square scale here. So you might notice that this looks different. It looks, well, it looks pretty good, I guess. The slope looks a little bit different, and the scale is, notice how the tick marks in the X's, if you kind of zoom in here, these tick marks, they're bigger than these, right? And that doesn't have anything to do with our scale that we did. So one way to sort of fix this, I think we cover this more in depth later, but if you go, do you see how 5 says zoom square? And if we go to our viewing window, we want, well, we may not be able, nah, you know what, this isn't gonna, we'll save this one, for later, because if we change the scale, we won't have a square zoom. We'll talk about that later. But here it is, it's pretty close. Sometimes there's slight differences, but you get the gist of it. We've got our graphing calculator graph here. And notice how it doesn't have any of the, it doesn't have anything labeled, right? So this here, we would need to label, this is 10, negative 10, and this is 20, negative 20, right? So there you have it. So we used our graphing calculator for our graph, right? So moving right along, we have, almost there, huh? We just have another graph down here. So this guy, you go about it the same way. So you pick what values you want to plug in. Why don't you go ahead and pause the video and see how you do. Okay, let's see how you did. I was thinking of plugging in negative 3, negative 1, 0, 1, and 3. So y will equal to negative 3 squared plus 1. So the negative 3 squared will be positive 9. You flip the sign on it, you get negative 9. You increase that by 1, and you get y is negative 8. So we get the ordered pair, negative 3, negative 8. Similarly, we do negative 1 squared plus 1. So we'll end up getting y equals 0. And then plugging in 0 for x, we get y is positive 1. And plugging in 1, let's see what happens. We get y is 0 again. So it turns out, I don't know if you remember this from Math 64 or wherever you took intermediate algebra, but this is the graph of a parabola that opens downwards. And parabolas have symmetry across the axis of symmetry, which in this case will be at x is 0. So this is why we're going to get repeating points that are the same units away from the vertex. And we'll get more into depth on that. But just remember, you can kind of get 2-for-1 points on a parabola if you don't want to work it all out. So this one will give us -8. So here we go. We've got our x and our y. This one we can just do our standard scale. So what we will have is we have an ordered pair at -3, 1, 2, 3, and then 1, 2, 3, 4, 5, 6, 7, 8 down. And notice that if we go to the axis here and we go 1, 2, 3 out, we get that symmetric point. It's symmetric with respect to the y-axis. If we folded this graph at the y-axis, those points would overlap. And similarly with -1, 0, and 1, 0. You see that? And then we get this guy, 0, 1. So our graph will look something like this. You know, I don't like this. It's too pointy at the end. You don't want it to be pointy. You want it to be kind of a smooth curve, and it decreases here without bound. Something like that. Okay. Okay, so we can definitely do this one on a square scale so we can really match our graph. So let's do it. So we go to our y equals. This one is isolated. So remember, the negative sign symbol is here. This means subtract. So we'll have -x squared and then +1 is our graph. And I want to zoom square. But I want my window to be -10 to 10 on each axis. And I want the scale on the y-axis to be 1 this time. Let's see what we get. And we get something pretty similar. Okay? So let's paste it below and check it out. I think I kind of got out of whack. All right, so there's the graphing calculator graph, and again, the scale we did on this one, we had done, this is x, this is y, 10, -10, 10, -10. Alrighty, so we now and we will wrap it up with an application down here. So a Major League Baseball diamond is actually a square, 90 feet on a side. What is the distance directly from home plate to second base? In other words, the diagonal of a square. So give the exact simplified result first and then round to the nearest hundredth. So what we're basically looking at here is when this guy has to throw someone out, what is this distance, this diagonal, right? So we can look at this triangle here, you know. We can just go this triangle here is what we can solve. And we have a right angle here, because we know that because it's a square. So d squared is 90 squared plus 90 squared, because the sides of the triangle are each 90. And so d squared will be 8100 plus 8100. D squared is 16,200. And then when you square root both sides, you would get the distance. We'll just take the positive root. The distance is the square root of 16,200. Well, let's consider 16,200 since we need to get an exact result. I know for sure that that's equal to 100 times 162. And 100's a perfect square, so I'll stop on that one. This guy's equivalent to 2 times 81, and 81's a perfect square. So I can write the distance as the square root of 100 times 81 times 2. So the distance will be, the square root of 100 is 10 times the square root of 81 is 9 times root 2. So the distance is 90 root 2 feet. The approximate distance will be, let's get our graphing calculator up. And if we do 90 times second square root of 2, we get approximately 127. It says round to the nearest hundredth, right? So this will be approximately, oh, I had the wrong pen, approximately 127, and that would be 0.30 feet. Okay. All right. So that's it, your first lesson. I know it lasted like 500 hours, but you'll make it, I promise. These first ones are kind of long because there's a lot of review material built in. So you have a fabulous evening, morning, afternoon, whatever time you're watching this, and I shall see you soon. Bye.